Alright, Math 1 Lab, we're evaluating functions. This time we're evaluating with tables, okay? So remember, the concept is our functions, the letter in front is the name, so f of x and g of x in this case. Notice that they correspond with this table being a g of x, this one being f of x, okay? And also, the letter inside is our input, so if we change it to a number, that's the input, and all of it together is the output. Okay? Or in this case, the x and the g of x. So it's pretty simple. We just started out like this. So f of negative 1. So I look at negative 1. What is it equal to? Because I want the output, because f of negative 1 means the output. It's 1. Then f of 2, my input of 2 gives me an output of 4. Now it says if f of x equals 4, what does x equal? Well, now f of x is the output side, and so I go back, and that's 2. If f of x equals 1, well, I know x is going to be negative 1. Okay? In that case, they were just opposites of each other. Okay, g of 0, 0 here, so that would be 1. G of 3 here, that would be 8. Okay, g of x equals 8. That would take us back to 3 for x. G of x equals 2. That would take us back to 1. Okay, number 3, f of negative 1. So, f of negative 1 would get us to 5. Okay, so f of x equals 5 would get us back to negative 1. Okay, then f of 0 is 6. So f of x equaling 6 would take us back to 0. And 4, g of 0 would take us to 2. So g of x equaling 2 would take us back to 0. G of 1 would give us 14. And g of x of 686 would take us back to x equals 3. Alright, so that's all there is to it on these. Okay, so plenty of practice so we know exactly what we're doing. F of 0 equals 10, f of 2 equals 20, f of x equals negative 10, take us back to x equaling negative 1, f of x equaling negative 20 would take us back and have x equals 1. Okay, number 8, g of 1 would be 100. G of 3 would be 4. So g of x equaling 4 takes us back to 3. G of x equaling 100 takes us back to x equals 1. Okay, g of 0 would give us 6. G of 2 would give us 24. G of x equaling 12 would take us back to x equals 1. And then 24 would take us back to x equaling 2. Okay, number 5, f of negative 1 would take us to 10. F of 1 would take us to negative 130. F of x equaling 10 would take x back to negative 1, right? And then f of x equaling negative 60 would take us back to x equaling 0. Number 12, g of 2 would take us to 20, g of 3 to 40, g of x equaling 5 would take us to x equals 0, and g of x equaling 10 would take us to x equals 1. Okay, number 10, g of 1 would give us 16, g of 2 would give us 4, g of x equaling 1 would give us x equals 3, and g of x equaling 4 would take us to x equals 2. Number 11, f of 1 would give us 1, f of 2 would give us 2, f of x equaling negative 1 would take us to negative 1, and f of x equaling 2 would take us back to x equals 2. Okay, number 9, f of 0 gives us an output of 150, f of 1, an input of 1, gives us an output of 160, an output of 150 gives us an input of 0, and an output of 170 gives us an input of 2. Number 13, f of negative 1 gives us 1. The f of 2, the independent variable of 2, gives us the dependent variable of negative 16. F of x equals 9, so dependent takes us back to the independent of x equals 1. And f of x equals 16 takes us back to 2. Okay, number 14. G of 0 will get us to 7. G of 3 to 56. 56 takes us back to 3. 14 takes us back to 1. So, should be plenty of practice here, right? F of negative 1 to negative 9. F of 0 to negative 8. Negative 8 back to 0. Negative 7 to 1 for x. And g of 0 would be 1, g of 1 would be 5, 25 would take us to 2, 5 would take us back to 1. Alright, so there's the first page. Okay, let's take a look at the second. Alright, so f of negative 1 is 6, f of 1 is 4, f of x equals 3 is 2, and f of x equals 6 is negative 1. 0 would be 3, g of 2 would be 48, g of x equals 48 would take us to 2, and g of x of 12 would take us back to 1. F of 0 would be 201, f of 2 would be 401, f of x equals 201 is back to 0, 401 back to 2. And g of 1 would be 50, equal to 50. Input of 3 gives us an output of 2. Output of 2, 50. Input of 0. Output of 50, 250 is 0. Of 50 is 1. Okay. F of 0 would be 5. F of 1 would be negative 6. F of x equals 2 would be 2 for x. And f of x equals 5 would be 0. For x. G of 1 would be 6, g of 2 is 9, g of x equals 8 is back to 3, and g of x equals 4 is back to 0. F of 1, negative 66, f of 2, negative 55, f of x equals negative 66 takes you back to 1, f of x equals negative 55 takes us back to 2. Okay, and g of 2 equals 11, g of 3 equals 11. So g of x equaling 11 could take us back to 0, 1, 2, or 3. Because notice we've got the same output for all of those. Okay, 25. So g of negative 1 is 45. G of f of 2 is 48. 49, and 50. Well, if we were to continue that, right, it would be 49 and 50 for 3 and 4. So they tried to trick us here into having to understand the pattern in order to finish it. Okay, g of 0 equals 1, g of 3 equals 27, g of x equals 9 has x equals 2, and g of x equals 1 has x equaling 0. F of negative 1 is 98, f of 0 is negative 2, f of x equals negative 102 is 1, f of x equaling 98 is negative 1. G of 0 is 1,296, g of 1 is 216, g of x equals 6 takes us to x equals 3, and g of x equals 36 takes us to 2. Alright, last row, last 4. F of negative 1 is 9, f of 3 would also be 9, so they tried to trick us on that one, but obviously the pattern is staying at 9, so basically any number that x would equal in this pattern would be the result of the output equaling 9. G of 0 is 3, g of 2 is 27, g of x equals 9 back to x equals 1, and g of x equals 3 back to x equals 0. F of 0 equals 10, f of 2 equals 20, f of x equals 10 makes x equal to 0, and f of x equal to 20 makes x equal to 2. G of 1 is negative 10, g of 4, okay, so we got to find the pattern, negative 5 to negative 10 to negative 20 to negative 40. You should see we're doubling, so it would be negative 80. G of x equals negative 10 back to 1, and negative 40 back to 3. And there we go, guys. Here's how we find with a table. Okay?